The broadcast is now starting. All attendees are in listen-only mode.
Hi, everybody. Thank you for joining us today. It's Lisa Travers from Alliance Corporation. This is a very special presentation we're doing today because typically we're doing this for people who don't really understand how it is to be sitting in a room by yourself talking to no one. But I think maybe a lot of out there, maybe you are familiar with how it feels, or at least how other people feel. In any case, I just want to give a brief introduction to how we're going to run the webinar and to our speaker, and who's going to do a quick introduction to the company and then go into his presentation. So we're using a tool called GoToWebinar, and it's really fantastic. It allows me to record the webinar, so I am recording it, and it's going to be available as soon as possible on YouTube, so you can watch it as much as you want or share it with other people. And I will be sending it out to everybody who registered for the webinar. The other kind of administrative item I wanted to mention was if you have any questions as we're going along with the content, please just type them in to the chat or questions, whatever you have on your console. And if it's appropriate, we'll address it. If I find the need, I'll interrupt Andy throughout the presentation, but otherwise we'll take them at the end of the presentation. And I think that's about it. If I think of anything else, I'll interrupt, but I'm going to hand it over to Andy, and we'll be probably less than an hour today, so hopefully we'll be on time. Go ahead, Andy.
Okay, thanks for that introduction there, Lisa. And thanks for everybody who's taking part in our webinar, Broadband Wireless Solutions for Broadcasters. A bit of background here. I'm the product manager for the Broadband division of Alliance Corporation. And my background is primarily on the technical side of the product management as opposed to the, let's say, the sales and marketing. So that's kind of the angle that I come from with this presentation, I think more so than anything else. So anyway, without any further ado, I'll talk to you a little bit about Alliance, just in case you're not familiar with us. We're a wireless distribution company. We've been in the business since 1993. Focus is, well, really on the points you see on the screen there. As far as facilities go, we have facilities in Canada, Mexico, and the U.S., 125 plus people. We have a manufacturing facility also in Mexico. Anyway, we pretty much, I think, have you covered as far as warehouse space goes and having product on hand. We specialize in personalized assistance from the experts in the industry, independent solution recommendations, and we certainly have many long-term wireless professionals working here. I'm working here for quite a while. I've been here 12 years myself, so I'll give you some idea. As far as product offering goes, you can see some of the logos of our vendors there. This is not all of them, but it's the better part of them, I would think. We like to think that we offer a best-in-class solution set. Top of the list there is microwave transceivers, which are product dearest to my heart, followed by antennas and cable. Just a note on the cable, and historically we have sold into broadcast entities quite often, usually corrugated, not so much semi-rigid, but maybe air dielectric cables and what have you. And of course, waveguides and the cable management accessories. Pretty sure you can read the rest of them there, so I'm not gonna dwell on that too much. A lot of people, just going by the list of people signed up, I think a lot of you are familiar with us anyway, but just there's your introduction there. As far as technical services, we like to think that we're a value-added distributor, and insofar as that, we offer technical services pre and post-sale. Some of the things we do are shown there. A lot of these things I head up internal to the company. As far as the technical training goes, that can either be product specific through our vendors, through myself. I'm certified to train on behalf of some of our vendors. After sale support is something we're very keen on here. It's support isn't a good thing to have. It's critical. It really is. The other stuff more to do with logistics, site kitting. I'm jumping around here a bit. But some things we do: path profiles, link budgets, propagation modeling, this kind of thing. All kind of key value adds as far as doing a successful broadband radio deployment. So anyway, enough said about that. I'm not big on tooting my own horn so much, so let's just keep moving on here. Broadband microwave radio applications for broadcasters. We put this together because we've had some success selling broadband into broadcasters, and the successes we have had, we've had a lot of really good positive feedback. So I'm certain that this is something that many of you can benefit from if you're not already. So there's a bit of a background on STL here. This might seem like a no-brainer for those in the broadcast field, but I also know from the sign-in sheet that there's a number of integrators and companies that have tuned in and maybe not that familiar with STL, but certainly have skill sets that would be brought to bear on this type of an application that would be extremely valuable. So that said, just bear with me if this seems like a bit of a review. So, as far as, I'm going to split this up a little bit, a background on STL, Studio Transmitter Link, specific to AM broadcast in the Americas, or medium wave, if you want to call it. And also, I put shortwave as well because I'm an avid SWLer, so I'm quite familiar with all the different broadcasters in the Americas with rather unique programming, I guess you could say. So I know that they certainly could benefit from the technology we sell. So anyway, with respect to AM, the broadcasters of AM broadcast, so I'm repeating myself here, the antennas themselves are comprised typically of 1 to 8 radiating towers of up to 300 feet, occupying several acres of land. These are generally placed between the intended service area and also any co-channel stations that are block interfering signals. So in this case, the towers themselves are the antenna. Now, when it comes to FM radio, things are a little bit different here. FM operates in the VHF band. Now here, the propagation characteristics are such that basically height is might. So the higher you can get your antenna, the more coverage area you're going to have. Typically, yeah, okay, I'll leave it at that. Anyway, it's just reference to the tall building, a mountaintop, and tall towers here, just to underscore the kind of locations where you would typically find the FM broadcast site. Generally not where you would find the FM studio. I think that's kind of the point of this whole thing. So as far as the last comment there, 2 or more FM transmitters may be used on a single broadcast antenna array. This is known as multi-coupling or combining. And you typically see this at sites where, I guess, antenna real estate is at a premium. If it's a very advantageous site, for instance, a tall building in the downtown urban center that you maybe don't want to completely decorate with antennas, you can put one antenna array and then multi-couple multiple broadcasters into the same antenna. So it's all rather neat, tidy, and efficient. In terms of high-definition television, things here are similar. We're using VHF and UHF frequencies. So once again, the higher you can get your antennas up, the more coverage you're going to achieve. 2 or more HDTV transmitters may be on the same tower, but in my experience, not often combined on the same antenna. Usually the disparity in frequencies kind of precludes that. So, I made some other comments. I was going to say that typically, or I shouldn't say typically, but oftentimes the television transmit antenna is quite a distance from the intended service area, and the pattern of the broadcast antenna itself is such that it steers the signal into where it will be needed. And oftentimes it can be many miles away from the studio and the customers. All right. So STL information continued. STL are almost always one-way links, and why is that? The broadcasting mindset is, well, with broadcasting, it's unidirectional in nature. And a failed studio transmitter link will be obvious at dead air on broadcast transmitter anyway. It's kind of a gross simplification, but anyway, I just thought I'd throw that slide in there because there are obviously exceptions. Historically speaking, STLs generally use 450 and 900 megahertz narrowband channels. Why? These have been in place for a long time. STL transmitters are typically 5 to 20 watts using a directional Yagi or grid pack style of antenna. And these are common sort of low powers for this type of equipment. And substations use 2 or more links, left and right channel perhaps, or redundancy, etc. Now, some of these analog links are digital now, and the reasons being our HDTV is digital by nature, so you kind of need a digital link. In the U.S. and in Mexico and Canada soon, we're going to have HD radio, which is high-density radio, and AM and FM broadcast. It has digital components embedded on the analog carrier. So many FM broadcasters carry digital data on subcarriers, financial reporting data, RDS, RBDS, etc. It used to be Muzak on those subcarriers. Perhaps it still is in some markets. The benefits of digital signaling are well known. Forward error correction, high signal-to-noise ratio, more secure, if that's a concern, etc. And I have actually run into a situation where the subcarriers were used for public safety, for things completely unrelated to what you would typically find on. Anyway, next slide here. Talking about, is STL always a radio link? And the answer is no. Many STLs use least copper or fiber optic lines. And some STLs use a combination of RF and cable connections to provide backup and redundancy. And some actually use the internet to link up remote transmitters, which probably not ideal, but sometimes it's the best choice. So sometimes the internet is referred to as the cloud. So features and benefits of broadband microwave STL. So sorry, just clear my throat here. Some of the benefits are we've seen and heard talk about of our remote storage of programming material. This could be uploaded, just for storage itself or to the transmitter in the event that there's a disconnect between the studio and the transmitter, so it'll fall back to that standby material. Offsite storage of enterprise information, backups with respect to disaster recovery plan, and even just for convenience, just to get it out of the office, as it were, and to store it away, archive it. Ability to stream remote CCTV cameras to monitor transmitter site for fire, intrusion, vandalism, base jumpers, weather conditions, access control, tower, top cams, etc. And also used to aggregate multiple STLs or video audio streams onto one microwave link with a view to reducing costs and system complexity. And to take full advantage of the SNMP features that are built into new broadcasting equipment. So, continuing on the benefits line, things that you could use or a wider bandwidth link for, or leasing extra data bandwidth to co-site users, whether they be broadcast, public safety, LMR, SMR, which is land mobile radio, specialized mobile radio, if you're not familiar with the terms, paging, weather radio transmitters, wireless internet service providers, others. It's really entirely up to you. I talk in slides farther on about how you can segregate data streams so one doesn't clobber the other. Use a transmitter site to provide high-speed link to other station facilities, offices, studios, transmitters, reciters, affiliates, news media, electronic news gathering, etc. Locate satellite uplinks and downlinks remotely, get them off the rooftop of the studio, and get them back all the information to the studio. And basically anything that can benefit from additional bandwidth in either direction. Benefits, the feature here being microwave radios use native Ethernet. The benefits here, Ethernet IP rapidly becoming the standard in all data communications. New site and power control monitoring equipment is all SNMP managed now. Low, medium, and high power transmitters have IP, SNMP for management, media upload, etc. Easy to implement new equipment on IP-based systems. It's largely plug and play. Plenty of networking expertise available. If you don't have it in-house at the time, you can certainly get it. As far as the feature, reduced costs, benefits, probably self-evident, but maybe some aren't here. Licensed microwave radio, all is cheaper than same bandwidth supplied by fiber copper providers. If you only own copper or fiber, then maybe this isn't true, but this is supplied by a third party. License-exempt radios, a viable option for many stations and situations. talk a little bit more about that later. Payback time over other solutions is typically very short, at least from our experience. So another feature, resilient audio over IP and video over IP connections. Benefits are not affected by tampering along the cable route. Backhoes, sometimes you hear the term backhoe proof, sort of tongue-in-cheek said, but it's certainly worth mentioning. Line noise and administration payment errors of those leaked circuits, aforementioned slide. Zero downtime, reduced likelihood of outage and interruption of revenue stream, of course. It's not on the air, you're not making money. Own and manage your end-to-end infrastructure. Important point there. So features continued software optioning of radios. The benefit here is you can option the radios for the minimum required bandwidth that you need. The ability here is you can conserve RF spectrum. You can also reduce the hardware cost and reduce the purchase price and oftentimes the licensing cost. It's particularly true in Canada where you have to pay based on how much information you're conveying across the link, not how much RF spectrum you're occupying. At a later date, you can re-option the radios via software if and when the need for greater bandwidth arises. I'll put the term future-proof at the bottom. I know it's a bit of an overused term, but I think it's valid in this instance. So as far as choosing the right tool for the job, not really a long list here in terms of the technology choices. At least I've kind of narrowed it down to what we call licensed and licensed exempt. Licensed exempt being the same as unlicensed. Pick the term that is most appealing to you, I suppose. So in terms of licensed exempt, PTP is a point-to-point link. Generally find that point-to-point is the right tool for studio transmitter link, not too surprisingly. So basically the application here is to use lower bandwidth, low-cost leased line as a backup to the STL. So you're not relying 100% on the licensed exempt radio. You do have a fallback here. You could also use it to bring on a secondary transmitter site. AM/FM simulcast or primary transmitter, we've done applications like that. Remote low-power transmitters, reciters to fill coverage gaps, we've done that as well. Provide the primary STL, so surprisingly there are some organizations that do that, most notably publicly funded ones, and special interest broadcasters that are under cost constraints. So you can certainly create a reliable link using licensed exempt equipment. Supply secondary STL path to transmitter site, so basically back up your primary leased line if that's a concern. Create a redundant ring between all of your transmitters and remote sites. We've certainly seen that as well. A very large network too is connected that way using licensed exempt products. So it does work and it can be made to work reliably. As far as the licensed products go, application is to, let's read the points here, supply highly reliable multiple audio over IP and or video over IP stream in a cost-effective primary STL. So as above for secondary remote sites, facilities, offices, repeaters, reciters, anywhere reliable connection will be a benefit. So facts and figures here. I'm just going to pause for a second here. Just have a drink of water. So some of the things that oftentimes we get asked about, in fact we get asked about them all the time, I'll touch on here. So in terms of reliability, microwave radio links are properly engineered, microwave radio links are properly engineered to have the same minimum availability target as leased lines, that being 99.999% uptime, also known in the industry as 5 nines. The technology is mature. The MTBF values of the higher tier equipment that we sell are into the decades now. So products are designed for and proven in and installed, and I might add, the most inhospitable places on Earth. Some examples below there, and these are all places we've successfully worked with our integrators and customers to install our products. Redundancy and failover. There are a lot of options available here. Some of the more obvious ones, hot standby is available in many products. Popular option more recently is what we call XPIC. Basically, you've got vertical and horizontal radios on the same antenna, on the same frequency, and carrying twice the information that they would normally. You can consider this a 2+0 link. So if one of the, from a hardware standpoint, if something were to fail in the vertical polarity, it would fall back to the horizontal, and vice versa. Hard switching to standby transceivers, you can do that. Generally, probably not a good thing for broadcasters. You want a kind of a seamless failover, but nonetheless. Radio networks, alternate paths, as mentioned before, we've done a few of these to create a redundant path. Failover to copper, fiber, analog, STL. And dual power systems run from the AC mains or DC battery. There's a few options there for keeping it up and running. So, signal fades causing an outage. All properly engineered microwave links use same standards of uptime as other mission-critical circuits. Fade due to weather always factored in. Dual radio space diversity configurations available for long-haul microwave links. And HAAM, which is hitless adaptive modulation, an option available when desired. Now, this is a feature that allows the link to operate at higher speeds when path conditions allow. Yet it will always protect your primary feeds, in this case your STL. I can talk more about this later. In fact, I think I do another slide. So, huge dish horn antennas needed. New technology radios are typically optioned with 2 to 4 foot antennas. This is somewhat band dependent depending on which region you're in. Like for instance, if you're in a high density area, it may be called upon to use a higher performance antenna. So these are, I'm speaking kind of in, not vagaries per se, but just planning numbers, I suppose, are fair for 2 to 4 foot antennas. But there may be cases where a larger antenna, 6 gigahertz is a good example, where typically your minimum antenna size can be about 6 feet in diameter. So, nonetheless, 1 foot antennas are available for use on 23 gigahertz and above. These may seem like astronomically high frequencies for those in the broadcast field, but in practice, these are actually very good bands, and certainly very little noise, and the gain of the antennas, even at 1 foot, is so profound that it overcomes the perceived, shortcomings of extra propagation losses in those frequencies. No minimum antenna size on license-exempt point-to-point links. They're a little bit more liberal in terms of what you can use for your application. Current transceivers are much more powerful and efficient than legacy equipment. Some example, well, there's an example below us here. There's a profound difference in the power and speed of the new equipment compared to the old. The radio in the palm of the hand there is DragonWave Horizon Compact, which is available primarily in license, but they do have an unlicensed model at 24 gigahertz as well. Radios like this typically, just as a point of note, are a very high speed. Their latency specifications of that equipment are sub-millisecond for the hop, so very quick. I gather that's a concern of broadcasters. So, interference issues, RFI, EMI, intermodulation problems. Every successful microwave license application considers all of this stuff, particularly with respect to interference to and from broadcast equipment. In case of area that's factored in, generally that's 1.25 miles, 2 kilometers if you're in Mexico or Canada. All better quality transceivers, you'll use shielded data power cabling. Waveguide feeds of microwave antennas is narrowband by its very, very nature. So it's not likely to be affected by even profoundly stronger signals from your broadcast equipment. Frequencies are far removed from the broadcast bands as well, of course. Successfully installed in some of the most RF hostile places on Earth. Yes. That's Mount Wilson in the picture there. Most of these are considered, most of these points are considered on a properly engineered, unlicensed application as well. Now, granted, you can put an unlicensed radio up pretty much wherever you please, but if you factor in the same sort of things that you would if it were licensed, you can end up with quite a reliable link. My notes are getting a little bit out of secure, but nonetheless, can they stand the weather? Radios are certified to IP67 and 68 standards, extremely high component tolerances, ensure consistent performance across vast temperature swings, designed to withstand wind speeds that living things can't, and can tolerate electrical surges, natural and otherwise. So segregation of streams, be it video or audio. The question posed here is, could my crucial STL signal be adversely affected by non-AOIP video streams? So all radios of note employ protocols to ensure that certain minimum levels of service are met. These are known as quality of service and prioritization, or if you like, 802.1q or P and Q, the terms they use. So I'll talk a little bit about those. So quality of service, sorry for the verbiage on the slide. It's not quite PowerPoint abuse because there are a couple of pictures on there. Anyway, I'll read what it says because quite frankly I couldn't explain it better than this. 802.1q is also known as VLANs or virtual local area network. It creates logical paths on a shared medium. There are many benefits to this, and for our primary concern, STL, each would have its own unique VLAN ID. Management of remote site equipment could also have its own VLAN ID, as would any bandwidth used for off-site data storage, security cameras, remote Wi-Fi hotspot for text, programming upload, or anything you want. The picture there, I don't know how clear it is on your screen, but basically shows how you segregate a portion of it for each piece of traffic. So by using VLANs, you can easily allocate logical streams and plenty of bandwidth to work effectively, i.e. you would allocate enough bandwidth for your STL so that even under worse conditions it wouldn't get clobbered. A VLAN will protect you from networking faults caused by another VLAN. Now, the example I use here is if you do perhaps have a regular networking connection at your broadcast or broadcast transmitter site, and if the technician or whomever else happens to plug into it and their machine is compromised through some spam mailing Trojan or something, if you're running a QoS, it's not going to have the ability to take out the other traffic. Whereas if you're not running QoS, it will most definitely take out everything if it feels it wants to commandeer the entire channel for its nefarious application. So next slide, prioritization. This is the 802.1p. Typically used in conjunction with the aforementioned VLANs to ensure that higher priority data gets sent over the link first. Typically, the 8 levels of priority are allocated 4 different queues. So the examples there, I'm using STI. I'm not going to read through all of these, but I think you can see that the STL would be of higher priority than access on the LAN side at the site itself. So these mechanisms are often referred to as traffic engineering in broadcast circles. So data segregation issues. Just thought I'd add this as a last minute thought. Note that it is possible to have multiple audio video streams set to highest priority, and with the use of individual VLANs, ensure that all streams have plenty of bandwidth available under all circumstances. Basically, if you had multiple STLs, you could make sure that one couldn't possibly clobber the other, even under some unusual circumstance. So probably a good time to mention that many cheaper license-exempt transceivers tout that they have these features. In fact, most of them do, I'll be honest. However, in our experience, they don't have the internal processing power to back it up. So audio and video over IP are unique in that they use much smaller data packets typically than your typical IP traffic streams, i.e. surfing the web or what have you. And it certainly uses more of them too. So what happens is the lower tier products can't keep up with the 802.1p and Q decisions. They need to make these internally because or they can't make these internally because the microprocessor runs out of cycles. So on standard TCP/IP, what you do in a case like that is you discard the packets. So that's obviously not a good thing in a broadcasting realm. So just be wary that despite it says that on the box, not all products are created equal. And obviously, in an application like this, I'm of the opinion that you really need to need the fine print to make sure you're not going to end up disappointed with the products that really don't serve it up. So as far as data security goes, remarkably, this is something that does concern broadcasters. You would think that you'd want to just transmit their signal and have everybody listen to it, but I suppose in the case where you're doing off-site storage or maybe backhauling satellite downlinks and what have you, this would be of some merit. Anyway, this is why I mentioned it here. Proprietary radios, typically of the type we sell, these are not open source. They're not based on Wi-Fi chipsets, or they're not shared platforms, with multiple different, private label brands. So this is not, anyway, I don't want to name any names. Anyway, the products are certainly unique and purpose-built for the application intended, not something that was maybe intended for indoor use has been modified for outdoor. So, as far as the data security, there's proprietary encryption and protection available on most of these, if not all the ones we sell. AES 128 is a no-cost option on a few radios, whereas AES 256 is an extra cost one typically. And for what it's worth, we do have FIPS 142 compliance on some models. Probably not a big demand for that broadcast, but never say never, I suppose. So, license exempts. So how many video, audio, data streams can a microwave link support? Kind of a difficult question to answer, but I'll try. And these are just kind of gross generalities here. So we're talking about license exempt products here. Typically, these are configured to provide 10 to 100 megabits per second for medium and longer haul applications. So in terms of HDTV, that could mean 2 to 3 uncompressed HDTV streams. As far as audio over IP, could be 50 plus stereo streams, plus the RVDS data as well. Shorter links in the license exempt space can offer quite a bit more bandwidth. These are different products. It's not the same radio. This would be an application where you needed to move copious amounts of video programming quickly between nearby facilities. The product at the bottom right there is made by Redline Communications. We're excellent vendor of products, and we've used them in many STL applications with success, I might add. That's probably key. Also, I jotted some notes here. I wanted to make mention of latency times for license exempt. Now, these typically are 3 milliseconds end-to-end when the channel is loaded, i.e. it's carrying traffic. So lesser radios advertise latency unloaded as opposed to being loaded, and often in a controlled environment. So something to keep in mind that it's very easy to sort of claim a low latency number, but like I said, once you load it up, things change very profoundly. The specifications we typically cite would be, like I said, 3 milliseconds, and that would be worst case, I suppose. So, and I think you can also extrapolate that. Sometimes the lesser radios, as far as the throughput specifications go, can be highly optimistic, to put it quite nicely. So, how much can we get over a licensed microwave? Typically 10 megabits in a 10 megahertz channel as a minimum. Standard radios operating in 50 megahertz channels, which is the maximum allowed, can be optioned for 300 to 500 megabits per second. These are full duplex numbers, by the way. To accomplish greater bandwidths, you can't go with wider channels because you can't license them. It's just the way that the bands are structured. So to accomplish this, you use 2 co-channels on the same antenna, which is XPIC, which we talked about earlier. Or you can use dual and triple channel transceivers. So you have one radio that has the ability to transmit multiple carriers, typically 2, but we are seeing more 3-carrier radios. And a combination of the above, so you can have multiple carriers plus 2 times polarity, and you can see through simple addition that you can be up over a gigabit per second, which is an awful lot of bandwidth. Certainly it's profoundly more than you would normally need for an STL, but I have seen customers option radios this high, like I said, for the aforementioned offsite storage of programming material, et cetera, et cetera. Another option that's available is bandwidth acceleration. This typically adds 40% improvement on the above rates. Now, and even passing, historically, how should we say, uncompressible streams like video, it does actually offer an improvement in performance. Also wanted to mention the latency of licensed products is very low, generally less than 1 millisecond per second end-to-end. So quite a bit faster if you want to be into the specifications than unlicensed. So that's pretty much what I have for now. I guess I'd like to open it up for questions here. I'm hoping that Lisa can guide me through this portion of it a bit. And yeah, I should maybe just, Lisa, are you there? Maybe I'll pass it over.
I am here, yeah. We don't have any questions that were submitted throughout the presentation, but Maybe we can address a couple. There was one I noticed specifically about worried about fading from environmental effects using Ethernet radios. Would like to use Ethernet radios at a 20-kilometer range. I mean,
Right.
maybe it would be good to explain what's the difference between an Ethernet radio and what people are used to using and the weather.
I guess, yeah, sometimes the terms are maybe erroneously interchanged between IP and Ethernet. But let's call it IP, I suppose, right? But in terms of comparing that to an analog radio, I guess you could say that IP radios, by their very definition, have forward error correction, and so inherently should be more reliable. But I'm guessing what the question is really concerned with is maybe more of the frequency issue, and I think I addressed that in the slide where I said that any successful application considers environmental effects, i.e. most notably rainfall, and you plan accordingly. So for instance, you have target availabilities and fate margins, and to meet those you may need to go to perhaps larger antennas than you had originally considered to offset the difference. But in terms of the 20-kilometer range, I'm looking at the question, and it's coming from someone in Alberta, and I know we've sold an awful lot of radios to Alberta, and most of Alberta is very forgiving in terms of what's required to get a reliable link on even 23 gigahertz. So it's kind of thing, contact me afterwards, and I can back that up with some numbers if some proof is required. Then not a problem.
Okay, there's another question that I know you do address some of these issues, but the question was about reliability, specifically in relation to running real-time data, live audio, and video.
Yeah, the radios are inherently reliable, and I think a lot of it comes down to, like I said, how the path is engineered. And I have heard a story or two where some broadcasters have noodled around a little bit with these radios, but generally not in an engineered solution per se, so their results have been less than stellar, I suppose, right? So once again, if it's properly engineered, the equipment choices are appropriate. You're not using radios that are made out of blow-molded plastic cases, this kind of thing. It's going to work extremely well.
Okay, great. There's another question. Are there such a thing as approved network switches to connect to wireless IP links?
Yeah, that's a great question. Yeah, we're in the wireless business here. We do sell RAD equipment, which is more on the wireline side, although we do have wireless products also. As far as specifically approved for broadcast, I'm not aware of anything. I know that Axia's equipment, we don't sell Axia's equipment, but their slant is really, they're very pro-Cisco, and they've got a list of recommended Cisco switches for their applications. So I'm not sure how else to answer that. We'd love if you bought some of our switches too, but I guess it's something that we could discuss later. But there's a lot of super reliable equipment out there.
Okay, let me see. No, I think that's pretty much it for the questions.
Okay, well that's fine.
Oh wait, now just 1 second. I do see if one has come in. Just a minute.
Okay, we'll give it another minute or two anyway.
Oh, it's a link. I can't refer to the link right now, but
Well, maybe it's
on a website for Air Fiber, I think the product is called, it claims 100-kilometer plus distance, which is quite a long distance. That's very true. UBNT, is that Ubiquity?
Yeah, we don't sell that product. I think that kind of falls into the aforementioned blow-molded plastic category.
Thanks, Jason. That's what it is. It is Ubiquity. Yeah. I mean, I know from my perspective, 100 kilometers is, I mean, you'd have to, not only do you have to have, you just have to have a lot of height.
Well, I know from the product itself, because, our customers, they dabble in other products as well, and that's fair. The Air Fiber is a lower cost, license exempt, high-speed solution. If I can be candid, it's not really in the same league that the products we sell. So, you know, I'm not enthusiastic about it. We've certainly sold people products to replace it, so I don't know what more to say. So, yeah, another thing maybe to consider is, and we have heard this from a broadcaster too, where the ubiquity equipment actually creates so much noise, it creates problems at broadcast sites as well. So it's, you know, it sounds like I'm beating up on it, but it's not without reason, I suppose.
There's one more. There's a comment, but not a question. That will probably, unless there's. Oh, there is one more question. What do you recommend for a configuration for a failover system using an analog STL microwave as a backup?
Yeah, okay. Our role is to provide the radios. We're obviously in the IP space and we're digital. For equipment like that, I can certainly, you know, put people on to the right product. The first place I would go shopping would be a company called Axia. They make products that are purpose-built for this kind of thing. I think Wheatstone's another one as well. They're kind of, they dabble in both places, but these aren't products that we supply. So I don't know if I could be much more helpful with that.
I think maybe he means using an Ethernet as a primary STL, but then the analog as backup.
Yeah, once again, that would be Axia or perhaps Wheatstone. Yeah.
Okay, sorry.
We're wireless. We're the wireless providers, and you know, we do have some Ethernet and IP stuff, but the focus is on wireless. So I'd like to say we're the full solution, but we're a distribution company, and we offer the wireless component. But like I said, if you wanted to follow up with us later, I could certainly help them out.
And then the last comment is really interesting. So we have in the opening slide, the background on STL HDTV, there was a picture used that actually belongs to Mike, who is actually on the webinar. And he says he's excited we've used our picture, but it wasn't labeled properly. It's actually CFRN and CITV in Edmonton.
Oh, really? Okay. All right. My apologies. I generally give credit where credit's due. Is it a case where maybe it looked an awful lot like this station?
I don't know. Well, anyway, we'll follow up after the webinar.
Yeah, I'm not one to rob people of credit, that's for sure. Okay. Thanks for that, Mike.
Okay, so that's it. Thank you, everybody, for joining us today. Like I said, I've recorded it, so I'll be sending out a link afterwards that you can watch. And if you have any questions at all, please don't hesitate to email me. I'll be sending out Andy's information, and if you have any technical questions, you can ask him. Thank you again for joining us.
Yeah, I just wanted to add, Lisa, that we're anticipating we'll probably run the webinar in another month as well. So if you missed it this time.
Not exactly in a month, but
well,
short.
Yeah, a month-ish, let's say. We're heading into the holiday. Yeah. So all right, fair enough. Thanks, everyone.
Bye-bye.